So let's talk about the Iron Man suit. Could we actually build one? It sounds like it's straight out of a comic book, right? Well, the answer is surprisingly grounded in some real hard science. Today, we're going to break down the physics of what it would take to make Tony Stark a reality.
Yeah, you heard that right. And before you just write this off as some comic book fantasy, just stick with me for a second. And don't worry, this isn't going to be some dry science class. The real answer is way more interesting than just a simple yes or no. You know, if the answer is no, well, then it's not a question of if we can build it, it's a question of when. It stops being science fiction and just becomes an engineering problem that we haven't cracked yet. So using that exact framework, let's put the Iron Man suit to the test. We can basically break it down into 6 main systems that have to work together perfectly. You've got the armor, of course, an exoskeleton for that super strength, a propulsion system for flight, a brilliant AI like Jarvis, a whole weapons package, and of course, the big one, a power source to make it all go. So let's see how each of these holds up. Let's kick things off with the parts that are, believe it or not, surprisingly close to being real. We'll start with the physical shell of the suit, the armor, and that awesome super strength it gives you. Okay, first up, the armor. And the demands here are just intense. I mean, it needs to be strong enough to stop bullets, to survive explosions and missile hits, but at the same time, it has to be lightweight and resist insane amounts of heat. That is a massive challenge for materials science, but it's a challenge scientists are actually working on right now. And the verdict? Totally possible, seriously. We're already cooking up advanced metal alloys and ceramic composites that are incredibly tough and crazy light. Now, are we at the taking a direct hit from a tank shell level yet? Not quite. But the basic science? It's absolutely there. All right, next up, strength. Obviously, a person can't just punch through a concrete wall, but a machine sure can. The suit would basically act like a wearable robot, an exoskeleton, using powerful motors, maybe some hydraulics at all the joints, to multiply the user's strength by an insane amount. So, giving a regular person super strength with a suit? Also totally possible. In fact, we already use exoskeletons in factories to help people lift heavy stuff, or in hospitals to help people walk again. This is 100% within our engineering grasp. Okay, so the physical structure. That seems pretty doable. Now let's get to 2 of the most iconic parts of the suit, flying and that brilliant AI brain. Now, you'd probably think that flying is the biggest hurdle, right? Well, what if I told you it might actually be one of the easiest parts of this whole puzzle? The basic tech, things like jetpacks and tiny jet engines, they already exist. People have literally flown using this kind of gear. The real challenge isn't inventing it from scratch. It's about making it way, way better in terms of control, stability, and of course, efficiency. So, yeah, strapping on some repulsors and blasting off into the sky, that's not really science fiction anymore. It's just a much cooler, more advanced version of tech that's already out there. And you know what? The same thing goes for the weapon systems. Yeah, they're complex, but they're really just miniaturized versions of military hardware that already exists. So from a scientific standpoint, that's achievable too. Okay, now let's talk about the brains of the operation. We all know Tony Stark has Jarvis, right? This seamless AI partner he can just talk to. But stop and think about it for a second. We have AI assistants in our pockets, on our phones. We use voice control for everything. And we're even starting to develop things like brain-computer interfaces that could let you control machines with just your thoughts. So a Jarvis-like system that pulls all of that together into one smooth conversational AI, that's not some giant leap into the unknown. It feels like something that's very possible in the near future. Okay, so that's 4 down, 2 to go. But I gotta tell you, this is where the easy part ends. And this is where we just hit a brick wall. There are 2 huge problems that are standing between us and a real working Iron Man suit. And these aren't just tricky engineering puzzles, these are things that push right up against the limits of what we can do with science today. The first big showstopper is the power source, the arc reactor. I mean, to power the flight, the weapons, the super strength, you need a ridiculous and absolutely insane amount of energy, all packed into a tiny little space. And this is where Einstein's famous equation comes in, E equals mc squared. What that tells us is that a tiny, tiny amount of mass can be converted into a gigantic amount of energy. So, and this is the key point, theoretically, a compact reactor like that is possible. But practically, we have no clue how to build a safe, miniature fusion reactor that you can stick on your chest. And look, even if you magically solve the power problem, you slam right into another one, G-forces. You know, a highly trained fighter pilot can handle about 9 Gs, that's 9 times the force of gravity before they black out. But when Iron Man just stops on a dime or makes a hairpin turn going faster than sound, the G-forces inside that suit would be absolutely lethal. They would literally crush a human body. To survive that, you'd need some kind of fictional tech called inertial dampeners, a system that could just magically cancel out all that force. And right now, that stuff only exists in science fiction.
So, after breaking down all 6 systems, what's the final answer? Where do we actually stand on building a real-life Iron Man? So, can we build an Iron Man suit? The answer is yes and no. This table really says it all. Most of the pieces, they're either possible right now or they're just over the horizon. The armor, the strength, the flight, the AI, even the weapons, they're all fundamentally achievable. But those last two, the power source and surviving the G-forces, those are the showstoppers. For now, they are still firmly stuck in the realm of science fiction. But, and this is the exciting part, just think about it. Think about flying in airplanes or computers or sending people to the moon. Every single piece of technology that we take for granted today was once considered impossible, right? Just a wild fantasy. History shows us over and over again that today's biggest challenge is very often tomorrow's breakthrough. And what that means is the person who's going to solve these huge problems, the one who's going to invent the real arc reactor or figure out inertial dampening, well, they're probably not a character in a movie. Maybe they're an engineer somewhere, or a scientist, or who knows, maybe they're watching this right now. Which brings us to one last question, and this one's for you. If this suit were real, all the problems solved, ready to go, would you put it on? Let me know what you think down in the comments. Thanks for joining me.